Hello and welcome to my video, lesson 6.4, solving rational equations. Alright, so solving, compared to what we've looked at so far, which is adding, subtracting, multiplying, and dividing, just changes meaning that we have an equal sign, but actually it's all of the processes we've already learned and put together. Okay, but other than that, it's actually the same as the last few topics. Let's take a look at some examples here. If you can try these questions before I do, press pause, try them out, and watch to see if you get the same solution I do. If you can't, watch along, try it along with me, and see if you can follow along and understand and learn something. Alright, so here we have, let's look, we have two different equations. I'm going to just put a little bit of space between them. And we're going to solve this first one. So what are we going to do first? We're going to actually have to worry about this adding sign first because if we want to use opposite operators afterwards to solve for the letters, we're going to have to be able to get rid of that. So let's take a look here and try to add these two terms together by factoring everything. So we have 2 over z minus 2, z plus 2, plus, so that's our first term, and our second term has 10 over 6 z plus, 6 bracket z plus 2 equals 1 over z minus 2. Alright, so looking pretty good here, but what we can do now is we can notice the things that are different between our different situations here. Actually, we can even notice that we can simplify this once, so hopefully that makes some sense, divided by 2 on top and bottom. So now what we're going to do is multiply by the missing components of the denominator. So here we have to multiply by a 3, z plus 2, which also means we have to multiply by a 3 and a z plus 2. Okay, and then over here we have to multiply by a 3. And over here we have to multiply by a z minus 2 and a z minus 2. It looks a little bit confusing right now, but it should make some sense once I put all of this together. So on the left side, we're going to have the same denominator everywhere. So let's change that right now. And on our right side, we're actually going to have the same denominator as well. Plus 2, z minus 2. Okay, and so we can now multiply these things out. So that's our right side. Our left side has 6 plus 5z minus 10, like that. And now you can notice that our bottoms have the same thing all across. Just be very careful before you actually start canceling anything out that you make sure you record your NPVs. So at this point our NPVs are z cannot equal -2, 2. Okay, and now we can continue on basically by canceling the bottom. So we'll have 5z minus 4 on the left side and 3z plus 6 on the right side, which means that we can just rearrange to solve. So we're going to put the -4 over, so adding 4 to both sides. We're going to put the 3z over by subtracting by 3z on both sides. So we're going to have 2z equals 10. Yeah. And then we're going to divide by 2 both sides, so that'll be z equals 5. And you just always double check that it's not one of your NPVs. and it's not, so we're good to go. All right, try that same method out on this next one if you can. All right, we're gonna try it out together. Always feel free to pause the video if you need to. So I'm just rewriting out the whole thing except factoring the parts that I can see. So x plus 2, no, plus 4, x minus 2, plus 6 over, oh, and I think I have to divide by 3 top and bottom, so 2x plus 4. There you go. Equals 5 over x minus 2. Okay, and this one turns out to be very, very similar to the last question. Actually, if anything, just a little bit easier because we have less to multiply by to make common denominators. But it's not significantly easier. It's just slightly easier. Okay, and now we can expand what we have and go from there. So the bottom on both sides, we have x plus 4, x minus 2. And again, like I said before, that's happening on both sides. 2x minus 4. And then on this side, whoopsies, we have 5x plus 20. And we have x plus 4, x minus 2. So before we can cancel anything, we need to make sure we record our NPVs. So x cannot equal negative 4, comma 2. And so once we do that, we can actually write everything down without the denominators. We can cancel out the denominators basically by multiplying by the denominators on both sides of our equal sign. But that lets us get to this point. Now what we can do is solve for x by moving all the numbers over, moving all the x's over. So we'll have 3x equals negative 22. So x equals negative 22 over 3. And that is not one of our NPVs, so it is our final answer. Okay, last question. It's going to be a little bit easier in terms of the math. However, it is a word problem, so that in and of itself means it's more tricky, generally speaking. So a triathlete can run 4 times faster than the same distance for swimming. To travel 200 meters, the triathlete needs an extra 90 seconds. What is the average swimming speed? So what you need to do is basically start drawing yourself a table of data. So here we can put running. Here we can put swimming. And we can have speed. We can have distance. We can have time. And we're going to basically make them all a relationship to whatever thing we can. Okay, so speed. To start with, we have the running speed is 4 times the swimming speed. So we'll call it, let's just go with x. So 4 times x. Okay, so this is going to be the same distance between both cases. So we're going to call it d. Oh, actually, the same distance d is the 200 meters, tells us. Okay, and time is t here, but t plus 90 seconds over here. Okay, so what we need to do here is we need to do a comparison between both situations in order to solve for the missing side. Basically, it's a system of equations, but let's go ahead and try to solve for that. So speed, there's a few different ways we could do it in this specific example, but we can go speed, which is 4x equals 200 over t, using our equation over here. And our other situation would be x equals 200 over t plus 90. Okay, so now we have two different situations, and we're solving it like a system of equations. So we can put well, actually, let's not do that. Let's take the x in this case, or the 4 in this case, and divide it. So we'd have 50 over t. Okay, now we can use our system of equation rules and just make these two things equal. So x equals 50 over t, which also equals 200 over t plus 9. Or 90, sorry, plus 90. Okay, now we can look at just this stuff inside here, and we're going to try to solve for t. Okay, so what we're going to do is basically take our t's and move them across. So we're going to have 50 times by t plus 90. And on the other side, we're going to have 200 t. So we're going to have here 50 t plus 4500 t, or just 4500, sorry, and then equals 200 t. And then we'll move the 50 t over, so we'll have 4500 equals 150 t. And then we'll divide by 150 on both sides, which maybe I should be able to do in my head, but let's just plug it in. 30. Alright. So t is 30. So what was t? Well, it was the time for the runner to go 200 meters. That's great, but it's unrelated to our actual question. Well, it's related, but it's not actually our final answer. We want the average swimming speed and the average running speed. So we just have to plug that t back in for t in both of these situations. So x equals, 4x equals, no, we could go just x equals 50 over 30. And so that will give us some speed here for the runners. Yep. And then over here, same sort of thing. We'll have 200 over 120, which I can simplify somewhat. Oh, that's the value of x. Whoops. That's the value of x. So if I wanted the running speed, it'd be 4 times that. 4 times 5 over 3. So it'd be 20 over 3. Whoops. Because it's 4 times. I made a mistake there. Okay. So those are our two different speeds. And I hope that this video helps you understand solving rational equations a little bit better. Good luck.